Welcome back. In the last lecture, we looked at the progress made in aeronautics. In this lecture, we will look at how to propel an aircraft. What you see on the screen is already a beautiful counter-rotating propeller. We'll see how that will work. So how do we propel an aircraft? Right? Of course, when you go to an airport, you see an aircraft, you see the engines hanging below the wings, but let's see how that actually works. And I'm going to show you that example with something which is very simple, something which we have done as kids and also as adults maybe. Yeah. So what do I have here? I have a balloon. Okay. So this is a balloon. Yeah. Similar to what is shown in the screen. Okay. Now the balloon has air inside. So air pressure is higher as compared to that of the atmospheric pressure. Because of the pressure difference, so the air tries to come out. Okay. Of course, I have now closed the exit of the balloon. Yeah. But if I would open it, so then the air inside would rush out. Yeah. And in that process, it creates a jet. Okay. So let's see what happens when the jet is created. Okay. Right. Nice play. So you saw that the jet is created, and that sort of propels the balloon. Yeah, so the balloon moves forward. Of course, the amount of air inside the balloon in this case was not much, so it just fell a couple of meters far away from me. Yeah. Why does that happen? Because of the pressure difference. Yeah. So the air rushes out. When it rushes out, the velocity of the air is increased. This change in the velocity of the air creates momentum. We know it from the Newton's second law of motion. And from the third law of motion, what we know is that any force has an equal and opposite reaction. And the reaction of creating this force is the fact that the balloon moves forward. Okay? So this is how actually an aircraft also flies. Now, one way of creating this thrust is like what we did in the balloon, but a propeller is also working on a same principle. So the propeller, the blades of the propeller, they push the air. Yeah? And when they do push the air, it increases the momentum of the fluid. That increase in the momentum of the fluid creates a force. That force pushes the propeller forward. Okay, so now let's again come back to this example of balloon. Yeah. So as I said, the balloon just went a couple of meters far from me. But if I want to do a theoretical exercise of, say, I want this balloon to go as much far as possible, then what else can I do? Yeah. So scratch your heads and see what solutions you come up with. Okay. So one of the solutions could be that this balloon is connected with a pipe to an external compressor. Yeah. So the compressor is producing high pressure air. This high pressure air goes to the balloon via this pipe, and then the balloon creates this jet, and this jet propels the balloon forward. Okay, better than what I did the demonstration here, but nevertheless, because the balloon is connected via the pipe, the balloon will not go far. Okay. Can we be a bit more smarter? Yeah? Yes, we can. Yeah. So what if we have a compressor, a small compressor inside the balloon? So this compressor, what you see, is taking the ambient air, it is compressing it, taking it to higher pressure, yeah? And this high pressure air then comes out of the balloon in the end, right? However, this compressor requires power to run. Yeah? This power can be supplied by wires and connected to the grid. Better than the earlier example. But nevertheless, we are still connected to the grid with a wire. That means we cannot go far. So what can we improve in this arrangement? Now, to run the compressor, we require turbine, yeah, or some kind of a power producer. Yeah. What if we also incorporate the turbine in the balloon itself? Yeah. But the turbine requires power, right? So how do we generate that power? So what if we carry a bit of fuel, yeah, and put a combustion chamber between the compressor and the turbine and burn this fuel in this combustion chamber, right? So the compressor actually compresses the air, takes it to a higher pressure, to the combustion chamber where we burn a bit of fuel, and this high pressure, high temperature air then drives the turbine. This turbine is actually driving the compressor. There is still energy left in the fluid. That energetic fluid comes out of the nozzle, yeah, and that will propel the balloon. Yeah. Will this work? Yes. This is how a gas turbine actually operates. So instead of the jet which is coming out of the nozzle, we could also utilize the power and to drive a propeller. Yeah? And this is how a propeller aircraft actually works. So when you look at an aircraft, yeah, a typical commercial aircraft, you would see the engines hanging below the wings. Yeah? The engines are sucking the ambient air. There is compressor in the engine which will take it to the higher pressure. Then there is a combustion chamber where the fuel is burnt. At the end of the combustion chamber, we do have high pressure, high temperature air that goes through the turbine. The turbine is driving the compressor, but there is still enough energy left in the fluid to come out of the nozzle at a high velocity. Yeah? And this change in the velocity of the air is what gives rise to the change in the momentum. And this creates the force. This force is the thrust. And as a result of this thrust, the aircraft moves forward. This is a schematic of a gas turbine. Yeah? So again, you see the air is going inside the engine. There are a set of compressor blades which will increase the pressure of this fluid. Then there is a combustion chamber. In the combustion chamber, fuel is being burnt. This high pressure air is taken to higher temperature. After the combustion chamber, there is a turbine. The turbine extracts power from this high pressure, high temperature air to drive the compressor. But there is still enough energy left in the fluid. Yeah? And this energetic fluid actually comes out of the nozzle. And when it comes out of the nozzle, the velocity of this fluid is pretty high. So this difference in the velocity of the fluid between the inlet and the exhaust is what gives rise to this change in the momentum. Okay? In the next lecture, we will see at different elements of the propulsion system. So stay tuned.